2 weeks program, right? So remaining relaxed is very important. How many? Present. Not many though, right? Not even 20% maybe. And you know the topic of this program is about Geospatial. Okay? It's vomiting out or giving lectures. So also how much you grasp. Then only the program will be successful. Okay? So I don't expect that 100% you grasp, but at least if you grasp about more than 50%, I would still consider the program successful. Okay? So that is, let's say, the expectation we have. We lower down our expectations so that at least we are relaxed. In between, there will be some lectures to get delivered by the some of my colleagues from your IITs, and also I think 1 or 2 guest lectures from outside. Okay, and that has been designed for the best interest of the program, so that it doesn't get boring. You don't have to see me every day. You don't have to tolerate me the whole day. So at least a couple of lectures per day is good enough. Okay, because our human brain is just designed to receive, I think, about 45 minutes maximum. After that, it gets kaput. You know kaput? Kaput means, in German we can say kaput means, it doesn't function anymore. It is true. So if we pretend that, if we remain vigilant, our brain remains vigilant for more than 45 minutes, I think that's not true. So it's optimized way around 45 minutes. We can grasp things. Then we have also some real life stories that how we can integrate them into our learning process. Okay, so it's very clear. So no stress. So first thing, stay relaxed. Okay. So today, this lecture, I'll be just talking about, briefing about the topic itself. Okay, that means what are the technologies that we are talking about? Although, how many of you attended actually the morning and afternoon session? All of you? Did you?
Yes.
Okay. So if you have any questions, you can stop me anytime. Okay? So you don't have to wait. You don't have to feel embarrassed. Think that, okay, sir will be upset or whatever. No. So a lecture would be more productive when it is both ways. Okay? It's not just one session. Okay, so then at least I will know the feedback, how much you are understanding, otherwise our Indian way of saying. Okay, so now let's talk about it. The first topic, if you can see here, this is my lecture, VP is my lecture. So Geospatial Technologies for Sustainable Development. So that means it's an introductory class to various geospatial technology for sustainable development. So there, if I try to break it down, so there are 2 aspects to it. One is the geospatial technologies, and the second part is sustainable development plans. What is sustainable development? How many of you are aware of it? Don't worry, I'm not going to shoot out the question individually. Just raise the hand. Okay, but we'll still learn. Don't worry, I'll still teach, so that everyone has to come into the same page. Okay, all of you. The whole class, I want to come into the same page. So then only the lecture becomes more effective and productive. Okay. So now, where is the point? Yeah. So I think this doesn't work because I don't stand in one place while giving lectures. Okay, it's very boring. So that's why you have to follow me wherever I'm going. All right. First, just to introduce where I come from. Okay. Obviously, I'm from India. But then I've flown from Sydney, and that is actually the location that you see, University of Technology Sydney. So that is our campus. So, which is, you can see the iconic Harbour Bridge, the Sydney Harbour Bridge, where every year, New Year, you can see it's one of the first countries who celebrates the New Year, right? And then there are many iconic places. For example, like the Darling Harbour. So many, which is just walking distance from my office. Okay, so it is a city campus. So we do not have a campus like this where it's green and all that, but we have many buildings and world-class buildings. So any of these buildings you walk in, you find that there is okay. So the learning experience for students is totally different. Okay, not that actually I'm trying to bring Indian institutions down, but just sharing that the kind of experience that actually we provide to our students. Okay. Why do you need this? Do you need this light? No. Okay. So for this lecture, maybe the next lecture, we will continue a couple of lectures, but this is the top outline, defined by the United Nations. Okay? Because look, we must understand what are those before we can talk about the technologies, before we can learn about the true component of actually, let's say, this ICT based technologies. Okay? Then I will introduce very briefly about geospatial technologies, because in the afternoon session, I think Professor Srinivas is going to talk about Introduction to Remote Sensing. Okay? Although I will be talking briefly, but probably he will be talking more detail about it. Then I will introduce about geospatial computing. Okay? Then various applications. This is something you will find interesting. So anything that you learn, especially in the theoretical perspective, if it doesn't have any applications, it's as good as like learning nothing. Right? So that is why the new education policy has come, right? That is essentially is what all about. Like in Australia, everything that we learn, it's all about practical test. It's nothing you have to memorize. Because I have grown up here in this country, and I have gone through that process, IITs and blah, 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 blah. Many of the things that I had learned in my entire school life, nothing I have practiced in the rest of my life. Okay? So that means they only do when, like memorizing all those things before the exam, mugging up, you know, like books after books. It's wasted, I would say. Why wasted? Because we have limited power also here, in the sense of memory. Right? Memories are limited. You know that memory is limited, right? Like the computer you have hard disk. So human memory is also limited. 100%. Because if I talk, let's say, if I'm giving a lecture, tomorrow, 3 days later, if I would ask something, I don't think you would remember that. Okay? Because our memory is also classified into short-term memory, long-term memory. Short-term memory is the one actually which one you relies on when you go for exam. Because the brain knows that you just have to memorize it for a short time. After the exam is over, it's gone, done, finished. Right? Have you all experienced it already? Yes. So you agree? I'm not telling something false information. Long-term memories are, again, it's not that you are putting effort, but also it can be genetic. Right? Like, have you ever wondered, have you ever noticed, you know, a parent would look or appear totally different, but a child would look totally different to the parents. Maybe the child would look something close to the great-grandfather. The nose would be similar. So that is what you call genetic memory. That means our human body, the genes, right? It carries that genetic memory. Right? Why I am sharing this information? Because based on these fundamental principles, the AI is being developed. Artificial intelligence essentially means memory. Right? We train the computer. Computer remembers something. And then we ask the computer to do a certain task. Right? So it's all based on memory, short-term memory, long-term memory, and so on. Okay? When a child, let's say, is curious, we all are curious. Once actually we are born, we do not know, we are experiencing new things about this life. Right? There's light. Because the child is when in the mother's womb, everything is dark. Right? So suddenly it comes out, everything is totally different world. Right? So everything you experience, basically you learn. Right? So that's why the child becomes curious, oh, there is a fire. Although elderly people, they advise him, no, don't touch. But child is curious, wants to know. So again, that is how the memory comes in. How much you tell also, you don't go to that memory process, unless until the child feels it, burns it. That memory remembers forever. Okay? All this information will be very useful when. So I do not expect you to memorize anything in this 2 weeks program. Like whatever I am doing at least. What's important is to understand the concept. Okay? Because if you understand the concept, it stays with you forever. Okay? And I am a true believer of like learning one particular software, you must practice it. If you understand the concept, you can develop on your own. Right? It's all about mathematics. And Indians are good in maths. Okay, good. So the applications there you can see. I do not know what are the different background that you have. Maybe we can have a little bit introductory, a little bit more once you open up. So then at least I know what background you come from. Because then you could envision that how this technology can be applied in your own field. That's important. Okay? So to excel, that is very important. Okay? Learning the technology and applying in our own domain. Okay? So I'll give you a lot of applications. It can be from urban management, it can be disaster management, it can be from, let's say, drought management, it can be agricultural, like yield estimation. So depending on what kind of background, you can think of how we can engage this technology into that particular applications. Okay? Then we'll just summarize. So every lecture we try to summarize, we have discussions, what you understood, and if you have any questions or discussions, we can discuss. Okay? Am I too fast? I don't have typical accent, so you don't have to wait. I'm an Indian accent, isn't it? So it's okay. Good. Now, let's talk about SDG, Sustainable Development Goals. So the United Nations has come up with 17 Sustainable Development Goals. Why sustainable? Because we know, the matter of fact, Earth is the only planet so far in our human history. We have only discovered one planet where life exists. Okay? Science has gone beyond blah, 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 blah has happened. But we know only that it is the only planet where life exists. Okay? And that means it's very, very precious. That means the blue planet is very, very precious. And it is a miracle sort of thing, obviously, because the positioning of the Earth in the solar system, that makes actually the life happen. Right? The distance from the sun, right distance from the sun, a little bit closer that you go, you will get burnt. Right? You go a little further, everything will become ice. Correct? So the right location the Earth is positioned, and also the tilt, the 23.5 degree that we have around the axis, right? That also makes all these weather changes actually in the Earth. Very, very unique. Okay? So if you do not appreciate it, the next generation finished. Because in any case, the solar system would collapse one day. And we have evidence of that. We have noticed in the Milky Way, Akash, right? So every day we are learning new things. 10 years ago we thought that, okay, so maybe the Milky Way is this size. Then we realized, no, that's more than 20 billion galaxies. And then they say that, okay, the universe is expanding. They say there is about what? Multi-trillions of, the number is just mind-boggling. Okay? And the universe is expanding. So that means we have not understood anything much. So that means when something is very precious, we have to make sure they are all sustainably utilized. Right? We'll talk about it. What are those and all these things. So therefore, United Nations has come up with these 17 sustainable goals. Let's just briefly talk about it one by one. One is no poverty. Obviously, the target is basically for 2030. So it started in 2015 with the target to achieve by 2030. So now we are in another 5 years. I don't think we are going to be there. We are going to reach there. Because there are still a lot of countries who are poverty issues, really free. I don't think India has the issue now. I don't know. But yeah, there are still many countries, Uganda, Somalia, those are the African countries where you have problem with not having enough food for the people. Okay? So they want to target that. That should be equality in terms of, at least in terms of poverty. Second, poverty means the definition is also there. What is the poverty? Correct? Right? When you didn't have a car, what do you call, cycle, okay? You always aspire to have a cycle because your friends are driving a cycle, riding a cycle and so on. But once you have a cycle, obviously you think that no, I'm still poor because someone is driving a motorbike, right? But once you get the motorbike, then someone else is driving a four-wheel drive. Then once you drive a motorcycle, four-wheel drive, someone is driving maybe a Mercedes Benz. So the definition has to come. What is that level of poverty? And they have defined all these things. Okay. Second is zero hunger. So zero hunger means obviously we have to have enough food. Okay. So and that's a big task because to protect, because we have limited resources. I told you. Because 70% of the earth is full of water, and that water is useless. Yes. Because it's solid water. Right. So we have 30%, and in 30% also, what are the lands that actually is where the harvesting can be done? I think that is only 1% of those. So imagine. Okay. So now these numbers are very important because then we all have to realize it. So that if we do not contribute individually, well, how can we think? It's like how in India we go by, public or government property means it belongs to someone else. It's not our property. Right? Yeah, this is the mindset unfortunately we carry. I'm treating myself as Indian as well. So don't get offended, okay? So this is the mindset, right? Because it doesn't belong to us privately. Public means it is yours. The government means you own that. The government is nobody is like sitting, the Prime Minister is there or party comes in, goes back. And we like that. Right? So we must be responsible towards actually as citizens to manage these resources. Okay? So zero hunger. But obviously for that, their duty is basically as a government to bring up with policies. The policies which is adequate enough actually to attain these goals. Okay? Third is good health and well-being. That means adequate health. Meaning what? Hospitals, this and that, all that. Yeah, all those things, right? And also mental well-being is a very something. It's like something we never spoke about it until the COVID came. Right? Mental well-being we don't talk about it, isn't it? We talk about it as a business as usual. Mental well-being is so important because if you are not in the right frame of mind, you cannot do wonderful work. Right? So that is something. Quality education. Education is the key to change the world. That is important. Gender equality, yes, that's very important. Because we don't discriminate based on the sex. Someone is male or female or whatever, that should not be. Right? Because it's a human. Then clean water and sanitation, that's a problem in India as well. There are still villages where we do not have adequate clean water. Okay? And sanitation is still a problem. Then you have affordable and clean energy. Okay? Then you have decent work and economic growth. Okay? But India is doing in terms of economic growth. It has already reached what, $5 trillion maybe economic. Then industry, innovation and infrastructure. But all these things have to be sustainable. That means not at the cost of damaging the natural resources that has been gifted to us. Okay? Let's say our population has been growing rapidly. If we keep on cutting the forest and then start building actually the houses there, there will be a time where the entire ecosystem will be imbalanced. Right? Because we know, we have learned in the school that the plant plays a very critical role in terms of absorbing the carbon monoxide and then releasing the oxygen. So, and otherwise it creates an imbalance in the ecosystem. So that is why. Then reduce inequalities. So if you do not have the equalities among the countries, the wars are inevitable. Right or wrong? Huh? If someone else is having a better life than you, then obviously one fine day you would say that just forget about it, man. I just go and just steal, just attack. If I'm powerful, I'd say I would attack. US is doing that. Right? So, and also in the Indian history, we have seen that. Right? 1,000 years people have come, invaded the country, taken the resources and all that thing. Okay? So, so inequality is also an issue. Then, what is that? Sustainable cities and communities, that's very important. Unfortunately, some of our tier 1 cities have become unsustainable. Go to Delhi. You live there, I think, sorry, how many of you are from Delhi? Okay, so I can safely say that. But those guys who are attending online, they do not like it. But yes, the pollution is too bad. The air pollution is too bad. Okay? So, first tier cities, even Pune is very polluted these days. Then responsible constructions and production. Then you have climate action, so that you keep the balance of the earth. Then lie below water, also that means sustainable fishing activities. Because if you do too much of fishing activities, there won't be one fine day. There will be nothing left, right? And also for this, there are a lot of fishes and a lot of species that are becoming extinct because of the climate change. You can't go. Okay? Then you have peace, justice, and strong institutions. But that's okay. That's political mode. Partnership for the goal. So obviously, in order to achieve for the entire globe, you need actually the partnership with among all the countries. Okay? So more or less, we know these are the goals that actually we are talking about, the SDG goals. Now, can I go back? How to go back? Okay, so now these sustainable goals that I mentioned, that 17 sustainable goals, so they have defined about 169 targets. Okay, so obviously for each goal there are specific targets, and all together they have come up with 169 targets. And for all of those targets, they have come up with the indicators. Indicators means measuring instruments. Okay, to know this, whether we are achieving or succeeding or not, whatever, we must have the indicator. Okay? So we are not going into detail about that. Okay? Then the time frame is given from 2015 to 2020, and all the countries mostly they are part of it, 193 countries. Okay? So sustainable development, if you try to read the theoretical way as it is, the way that it has been mentioned, it is the development that meet the needs of present without compromising the ability of future generations to meet their own needs. It's not that we don't care. Because human life maybe is about 100 years maximum, 110 years, if you're lucky. So, why do you care? We live, when we go. Why do you care? Right? That's not the case. So that's we have to make sustainable. Now the question is, how the technology can play a role here. So this is where the Earth observation comes in. Earth observation means satellite images, observing the Earth. Okay? So, also the drones, there are also Earth observation techniques, right? So like 20 years ago there were no drones, but now we have, the technology is also becoming so much cheaper and cheaper and cheaper by day, day by day. Okay? So, using those resources, we can extract the information and the knowledge from there, and then gather the knowledge, try to learn from what is happening, what has happened in the past. Okay? Establish some equations based on those relationships. Okay? Equations means mathematical formulation. That's why the AI, the data-driven approaches, the statistical models and everything, all these modeling tools comes in. Okay? In order to predict, because then only we know, right? Let's say you simulate, given the way, now the question comes in, given the way India has been growing, given the way the population has been growing in India, in 50 years time, how would you predict the cities would look like? Now this is a problem. Okay? Right? So if this is the problem, what would be the answer? I can tell you for sure, yes, we can do it. But now how to do it? How to do it? Prediction, yes. Yes, prediction, but how do we predict?
Machine learning.
Yeah, machine learning, but this is very vague, very vague. But how?
By learning the previous trends.
Right. By learning the previous trend. Because we are not just going to actually Kailas and then sitting down and doing, yoga and then we learn. No. Some powerful people can do it. Yes. I'm not denying that. So for a normal human being, obviously, for scientific based assessment, you need to learn what has happened. Okay? What has happened in the past. That means that is what we essentially call it as the trend. How the trend has happened. So now we learn about the trend. Then we can bring all the parameters and the variables and all that. And then we know that we have tools that we have. We can tweak, change, and we can predict. Okay? So that is what exactly we are going to do in this class. Okay? Good. So at least first 20 minutes into the lecture you already know a bit what we are going to do. Okay? Now let's talk about what are the technologies for sustainable development. Now, remote sensing systems are extremely useful. But yesterday NASA has already pulled out a very, very important mission that they have been part of it from NOAA. So NOAA is the weather forecasting system. And our new President of the United States, he has now decided to pull out most of the programs. Okay, and India is one of the countries which is going to be affected the most. So overnight they cut off a lot of jobs in NASA, saying that we don't need it anymore. Whatever is needed for our country, we just do it. So that is where the sustainability comes in. That is why the Make in India program comes in. Because if you borrow technology, you keep on buying the technology, it's not sustainable, right? Because you are paying. You are paying, and then if what is happening in Israel, well, it's political, but what I'm saying is also that you can understand, right? So when you're too much dependent on external resources, right? So but luckily, India has already also developed a very solid satellite systems. Okay, so why remote sensing systems are useful? Because we are talking about the Earth. So we need a platform from where you can be able to monitor the entire planet. Right or wrong? Isn't it? So in order to monitor the entire planet, you have to go far. The closer you come, the little you can see, but more you can see. More detail you can see. The little further you go, so your field of view goes bigger. Your synoptic view gets bigger, right? So therefore the satellites, depending on its applications, they have launched into different orbits. Some of them can be in 400 kilometer range, some of them can be in 10,000 kilometer range. And they are in those orbits, okay, revolving around the planet. We have launched satellites very close to the sun, just to understand what is happening on the surface of the sun, the solar flares and all those things. Because they are very threatening, they are very dangerous, isn't it? So we need to understand why it is important, because we know the matter of fact that we have a planet, sister planet, which is Mars, exactly similar size in terms of Earth. But what happened to it? We don't know. Why today it has become red? We don't know. Right? Was there any life existed before? We don't know. That's why we think we are stupid. We are actually spending billions of dollars. The whole world is investing in that to launch vehicles to go collect the data to learn. There are evidences whether there was life existing. Because if we do not know, we must know those information that can be the fate of our own planet. Okay? That's right. So science is being useful. So remote sensing systems, because you can't use the maximum the farthest that the human being has ever gone is to only to our own satellite is called Moon. Moon is a satellite. Okay? Because it's a natural satellite.
Yes.
But these are, I'm talking about the man-made satellites. Okay? So the farthest the human being has ever gone from this planet is Moon. Right? That's all we have done. And the universe is endless. Okay? Yesterday, there was an article that NASA has discovered, not far, about 20 million miles from us, they have detected actually the laser signals. So it's the jadoo from that, what movie? Vermilion. But we don't know. 100% could exist. We don't know. Right? So, but they have detected, and laser means, that means that civilization must be very, very advanced. Because laser we just have discovered lately. Right? X-ray and all those tools, so you have just our great-great-grandfather, they didn't know. 200 years ago, there was no X-ray. Right? So, we don't know. There could be parallel universe, there could be molecule universe and all that. Right? But we know only this is the planet that we live in. So, it's very, very precious for us. Okay? So, remote sensing systems are being classified. If you try to define it in a very classical way, that means when you collect the information about an object without coming physical touch with the object, that is what you call remotely sensing. You are sensing now, remotely sensing everything that is happening around you, surrounding you, right? Isn't it? So visually you are sensing, you can be able to see me, what I'm doing, what presentation I'm giving and all that. Also your skin is sensing the temperature. Right or wrong? Agreed?
Yes.
Also, you are sensing, let's say what do you call it? Your nose is sensing, whether it's a foul odor or it's a very nice smell. Your friend has put actually a nice perfume or so on. Correct? So these are all sensing tools. So already this is what? Natural. So we are naturally sensing it without even knowing it. Okay? It's been designed in a way. Okay? And we react to it. The moment we feel that a bit hot, then we say, oh, please increase the AC. Right? Or too cold, okay. And vice versa. Right? But still we have very limited sensing ability in terms of seeing through. Okay? Now you pay attention. In terms of seeing through. Because if you look at the light that is coming from the sun, it takes about 8 minutes. Okay? We say sun has set. The sun has never set. The sun is always there. Okay? We have moved. Right? Well, but you've got to still define it. That's why you say sun is setting in the horizon. Very poetically you can say that. But sun has never set. Sun is there. We all are moving, sun is moving, we are moving. Okay? But we have, earth has moved. That means the other side of the earth is now facing the sun. If the sun is set, we are doomed. Right? Because we are positioned there because of the gravitation. Right? Are you understanding me?
Yes.
Okay. So, what else?
Position here because of the
So the sensing ability of the human being. So when the sunlight comes in, it takes about 8 minutes because how many million miles? Okay, exactly, you can Google it. So it takes to travel that light in the vacuum space. And remember, space is dark. Space is dark. Okay? So to reach the light, our atmosphere, then once it hits the atmosphere, we see the light. Because the lights get scattered. Now you recall back your physics in your 12th standard. Right? The lights get scattered. Okay? Now if you decode actually that sunlight, what do you call that actually? The electromagnetic spectrum. EMS. Okay? So when you decode it, it has got a wide range of wavelengths. because light propagates through wavelengths of frequency. That's the only way that we measure. And we know they are inversely proportional to each other. Wavelength goes up, frequency goes down. And also we know at what speed that light travels. 3 multiplied by 10 to the power 8 meter per second is huge. Okay? Now, what all the lights that you see, only a very tiny window that we could see through. A human being able to can see through only that tiny window. But there are still a lot of rays that electromagnetic spectrum has. One classic example is the gamma ray, which is very, very cancerous, right? In Australia, the ozone layer is thin. And there are some holes because of all this climate change that are happening. So obviously we have a lot of skin cancer. But lucky Indians are very good. We are blessed with a very robust color. So don't feel, that you are dark. It's a blessing. Because the pigments, it makes you robust. Yeah, you don't laugh. So you don't have to put actually fair and lovely to make yourself Again, that is a discrimination, I'll tell you. So when you sell a product saying that fair and lovely makes you what? Fairer. That means someone is dark is what? Unfair? What? Inferior? Right? So that is also the SDG goal. In Australia, see, regardless of your personal belief means the religion, regardless of whether you are a gender, whatever gender, male, female, or maybe the both of it, okay, one should not question and one should not actually discriminate other because it is highly, highly punishable in the name of freedom of expression. Because you must respect the human being. Okay? So, coming back to this. So, imagine huge ray spectrum. We can see only small, tiny, and if you try to actually decode it, it's about 0.4 to 0.7 micrometer. Okay? But we have radio waves also in that. Right? We have also gamma ray, we have also X-ray. Right? But we can only see 3 from 0.3 to 0.7 micrometer. Beyond that, we can't even see. So imagine how perplexed we are. So much of limitations that we have. But yet we say that we know everything. Okay? So now, how to know that what is happening and how these rays are coming, when these rays are coming and interacting with our atmosphere, with all the surrounding environment, including the rocks, the water bodies, the plants, and everything that is existing, how do they react? So fortunately, we have developed these systems, okay, which can be able to capture how it's reacting with this, and then we decode it, try to put it in image format. That is what is called remote sensing. Okay, so everything we get nice photographs. Whether it's black and white. Black and white means you have only one channel, right? Or you have color. That means you have multi-channels. So one good way to explain is this: when you're taking your photograph using your smartphone. Okay? Now in your smartphone, obviously you would like to have a very, very high resolution photograph. That's why these megapixels things comes in, right? So that very nice image. Then you can do the editing, the wrinkles also can go off. Then you can do the photo, what you call the color balancing and so on and everything. The same thing happens also here. And that the whole science of doing that is what you call digital image processing. Did you have to learn anything? Did you have to memorize anything, whatever I have taught? So science has to be taught in a very exciting way. Not just if I come actually start with electromagnetic spectrum. This is what it comes. This is lambda equal to this mu c. C equals to 3 into 10 to the power 8 in a second. This is what. After 10 minutes, I'm sure that you all will be out. Okay, so now coming back to that. So again, that remote sensing systems, there are different types of remote sensing systems. Okay. Again, I will tell you from the experience that you have experienced so far. You go, if you are broken your bone, you go to the doctor. Doctor says go and get the X-ray. Okay, that's remote sensing. Okay, so the photograph that you see, that is what? It's not a colorful photograph. It's a black and white photograph. But then, when you are taking a photograph using your own camera, you are seeing a very colorful photograph. Right? Right? Now you think about your phone that you are using to take a photograph. Right? So during daytime, when you take the photo, when the natural light is enough, that means the sunlight is enough, because sun is the external source of light, right? Energy also for Earth. Okay? So the photograph comes of better quality in terms of sharpness, brightness, blah 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 blah, depending on the sun conditions. If you are facing the sun, and if you are facing the sun, taking the photograph, obviously it's very nice, right? But from the opposite side, if you are taking, it's dark, right? So the key point here is, depending on external source of energy, the quality of the photograph changes. That is what you call an passive system. That means you are depending on an external source of energy for collecting data. Passive. Active means, regardless whether the sun is there or not, I still would be able to generate my own light source of energy, and I can generate, it goes and interacts with the target, comes back, then I capture the signals. That is what we call active sensing systems. Okay? And also there are many classifications in that also. So based on this, we have classified actually, or we have designed actually the satellites as well. Okay? All these sensing systems we have designed like that. There is another one. It's called now. It won't come because why? Because that's a TV, right? That's a TV. Here it would come. So LiDAR. LiDAR is the acronym for light detection and ranging. Okay, that means this is the laser pulse. Right now. But this laser pulse has limited wavelength. Okay. See now the plumber. Have you seen the new tools actually the plumbers are using for measuring the distance? They don't go and bring actually the tape and all that, no? It's all gone. So they just stand here, they put the thing here, and it shows what is the distance and very precisely. So what does it do essentially? It knows at what time actually the source of energy has been released, at what time actually it has collected energy. And we know what is the speed of it. Then its distance is very simple physics. The traffic police, when you're driving a car, they are also using the laser signal. Yeah, they have some air. They just beam at you. They know they are sending the signal, right? And then the incoming vehicle, or particular T0 at particular location, but now the T1, oh, it has traveled maybe 130 km/h. Then they will catch you, right? So that is also remote sensing tools. Okay. But this remote sensing technology was not designed actually for Earth observation. The whole development of the remote sensing was done during the World War, after the First World War, because they wanted to spy each other. Okay, what is happening in Russia during the Cold War? Okay, but our old Indian civilization also used to use the remote sensing, sending actually the letters through kabutar. Okay, we don't know. Maybe that was a very sophisticated people, and Ravana has a Vimana, right? I mean, look at actually even Mahabharata. someone is sitting 1,000 miles, or maybe hundreds of, not 1,000, hundreds of kilometers far from the war zone and telling the story the way it is going. It's like telecast. Sanjay? Right? Maybe the technology was existing, something would have happened. Because we don't know what the evidence we have seen in Mohenjo-daro. That civilization we have seen, it was a highly sophisticated civilization with so much of proper sanitation and the drainage system, and there was a bathing system. They had actually what? A public pool. Right? So, obviously there are calamities are coming in between. Okay? Earth is also going through, it's a very dynamic thing is happening. So maybe some information that those civilizations had, it was lost. Okay? But otherwise, how can, see, you can only imagine things that what you would have experienced. Otherwise, you would have seen. Right? You know how we learn how to fly. Wright brothers are the one actually who invented the aeroplane, right? Aircraft, right? How? Because they observed actually how the birds are flying. And look at the design of the bird. And if you look at actually all our, what you call, the aircrafts. So you can only do what you have seen. Otherwise, how can you think? It's impossible. Okay? So that is one. Second thing is, have you seen when a snake catches its prey? Have you seen? In the dark. You know how does it catch its prey? Spot on. When a snake catches a mice, in the dark, spot on. It's not actually, it's just, that's a sensing thing that they're using. Thermal sensing. So all this we observed outside, in our environment, we try to understand, then we develop actually the tools. Now we are using for our own applications. Okay, so this is something done. So one part is remote sensing systems. The second part is called geographic information systems. It started as geographic information systems, but it is now called it as geospatial information systems. There are so many names to it, or geoinformatics and blah blah blah. But essentially, when you have a lot of data that is coming in, you need a hardware to store the data, right? You need a software to open the data, process the data, analyze the data, crunch the data, visualize the data, simulate the data, and etc. and etc. Query the data, right? So that is why the geographic information systems has become very, very popular. Okay? And in the morning I have mentioned, right? You all are using GIS. The good example is like Google Maps. Okay? Point A to point B. How is it telling? Also tells you whether to avoid the tolls or not. Also tells you the traffic is there or not. Imagine. 10 years ago it was unthinkable. You know? I mean, in your lifetime you have seen that. How technology has been rapidly changing. How many of you have used the Nokia phone? The old Nokia phone to view the antenna. Or maybe after that the vibration comes in and all that. You would have seen that, right? Where did it go? The failure of Nokia, although Nokia was one of the most successful phone company, was because of its inability to adapt to the new technology. Okay? With the changing environment, you've got to change. There's no way you'll be left behind. Okay? Now, you can call anyone at any given time for free. And there is FaceApp, there is WhatsApp, there is this and that, for free. You know, when I was in IIT Bombay those days, and I had to call home, I had to use the STD. You know the phone booths? More than actually talking, it's about looking at actually how the meter is increasing and how to be beating. So you've got to make sure that the sentence is very whatever you wanted to say, important message has been delivered. You don't have actually the luxury of sitting down and talking to your mom nicely, okay, kya khaiye, right? But today, you guys are freely talking at any given time, right? So the technology has changed, right? So GIS is a very powerful thing and it has been used in many areas of applications. Even the doctors, like I have few PhD students I have graduated working on medical data analytics. That means early detection of the breast cancer, let's say. Okay, because you have different stages of breast cancer, for example, and it's very, very common, especially in the Western countries. Okay, so if you could diagnose at a very early stage from the images that you are taking, okay, then probably you can avoid actually going into the next stage of the cancer by using AI based. Most because you are using X-ray and all those things anyway. Anything that you are using images, that is remote sensing, right? But again, how to read those information, that is the key. What do you want to read? That is the key. See, today you have so much of information at your fingertips, right? Google Baba is there. Google Baba, whatever you ask, it can tell you everything, right? What information that you want to extract, that's very important. Too much of information also can be very, very confusing. No? Right and precise information is that's what you need. Our Indian way of always telling is very elaborate, you know. Indians are very good in telling stories. Agree or not?
Yes.
Whatever is supposed to be told in just in a very precise 2-3 words, we give a preamble to it. Then there is a process to it. You know? Yeah, because we are good storytellers. Okay. So coming back to this. The third field, technological field, is called GPS. Why GPS? Because the location is very important. Without GPS, your Google Map is meaningless. That's why your phone has got GPS, right? It's not 100% accuracy. What accuracy? It can be about maybe a meter or two. Okay, but when we use the GPS, the sophisticated professional GPS, that is into sub-millimeter accuracy. How do we do that? Because we have the reference point in the as a satellite. So at any given time, we need 3 satellites to do the calculation of the position. That's what we have studied in our civil engineering as well, right? Okay, so the positioning is very important. And GIS means it has got locational data. It is not just any sorts of data, it is data which is spatial. Spatial means reference to something. Some coordinates are attached to it. But again, the reference can be a local reference or it can be a relative or absolute reference. Relative means?
Reference to some local.
For example, if I would say that define my location right now, me, you can say, I mean, from the wall north, because right now your north is this, right? And this is a local reference system that you are creating. And it's a relative, maybe about 6 feet or 7 feet from this, and maybe this, and then you can do so many things actually you can define. Absolute reference system means that is the reference that is in terms of coordinates, the UTS coordinates, or there are so many coordinate systems that we have, right? But there are challenges because Earth is spherical, and we got to actually read the map in a flat, 2-dimensional. So obviously some mathematical calculation need to be done. This need to be fixed. That's why this. So GPS is very, very extremely important. Then, in order for us to analyze the data, so we also need some mathematical tools, models, right? So that is where actually we need some systems. Okay. So I just put like warning and forecasting systems and all that. but it can be of anything. And then the IoT technologies as well, Internet of Things, you know, like we have so sophisticated now the IoT IoT equipments, which is so cheap, like collecting data about the temperature, pressure, humidity, this, that, and all those things, right? So there is a science by itself, right? IoT sensing, IoT based sensing. And then how we can connect that actually with the internet, so that in a real time we can collect the data. As we see through, we are collecting the data from the field, and it can only be achievable if you are using the Wi-Fi or internet things, right? Then obviously the communication technologies. So any problem in so far? So these are by and large actually the technology that has been used. Please tell me when the time is up, because otherwise I would keep on going. No? Okay. Break time? So this is the problem. Yeah. But okay. Now let's look at actually the origin of geospatial. It's not actually very old technology. You can see here. It started off back in 1975. So it's about 50 years ago. But it was dormant. It was dormant for almost about 10 years. Okay? GIS was developed around that time, but the computing facilities were not developed at that time. Right? So even when I was in IIT Bombay those days also we had that 486 computers, which we used to have the floppy disk. You know what was the memory that we can carry the data? 64 kilobyte. Yes, the size of your photograph actually is much more than that now. So imagine what you can carry. So the first time when I went to IIT Kanpur, I went to Germany to analyze some data and all that thing. I had to carry the data, the satellite data, in a tape. Okay, so I had to go to the computer center, centralized computer center in the campus. So they encrypted and everything put in the tape. Then I went to the Germany, the university's main computing center. Then they had to, there was no CD. CD came actually, where is CD today? Right? Even the hard disk is also getting obsolete now, because everything is now cloud. Right? So if you can see that, because they are all interlinked together, so therefore the technology really didn't shoot up much, and also people didn't know the utilization of the power of the technology, the GIS technology. When it came to 90s, that's why actually the computer stood up. That's why actually India also boomed, you know, in 90s. IT becomes, before that computer science was nothing. Everyone wanted to do actually computer science at that time. Right? And all the Indian companies, they started doing well. The TCS and all these companies, they started doing well during that time. Right? And you could see it started actually taking off. Then, well, the new name that actually come, before they used to say geospatial, they started telling geospatial, one name. Okay? People also call geoinformatics. And today Professor Dheeraj was telling also, it's called nowadays, it's called GeoAI, Geospatial Artificial Intelligence. Okay? Now, let's look at what is geospatial computing. Geospatial computing basically is a set of computational tasks, okay, that involve geospatial data or information. So not just any sorts of data, but geospatial data or information. That means, as I mentioned, the data which has got coordinate system, right? That means X and Y. Because even your satellite data, okay, forget about satellite data. When you're taking a photograph, right? You have stored. Now a year later, Google is reminding you, hey, last year, May, you visited this place. Right? Google reminds you. Why? How? How? Because when you have taken the photo, it has been geotagged. The location has been geotagged, and it has been stored actually in your Google. Right? And then your anniversary time. Anniversary means not about wedding, talking about that, right? So locations is a very important. So that's what exactly I mentioned. Geospatial data, geospatial information refer to the data that is partially referenced with respect to the Earth. Okay? That means coordinates basically, x1, y, lat and longitude. Okay? And the system, geospatial systems have two components. One is spatial structural components. I'll give also a lecture on GIS as well. I think tomorrow, day after tomorrow, you will learn more about it. How the data is being structured, and then the relationship between the data is very important, and so on. Okay? So one is spatial structural component, another one is spatial interaction component as well. Okay? And then it has got different subsystems, human subsystems, physical subsystems, activity subsystems, and so on. But that is none of our concern for the time. Okay? We don't bother much about it. Then the second component is called computational models. Whenever there is a data, our human mind has limited ability actually to read through the data. We even haven't memorized actually the periodic table. How many of you are successful? I could never. Okay? Periodic table, you know, H-E-A-I, okay? Then the, what do you call the maths that we, Table. Okay, I think we, until 25th, I think we go. 30. So he has better memory. Okay, but we find the way how to solve it, right? So you need some computational models when the data becomes abundant and our human mind goes bust. Can't be able to explain, confused, can't do it, right? Let's say 100 years of data. Okay, you want to analyze crunch, get some information about it, you can't do it, right? So that is why you need the computational models. And how do you define the computational model? A computational model is basically a set of computational operations performed in an order to generate pattern from the data. That means it is just about getting the information from the data, what kind of pattern it has in the data. Okay. Now you look outside. Have you observed actually the trees, plants, the leaves, the flowers? Okay? These are gifted things. We haven't put any effort actually to do this. This is being there, right? You could see the way symmetrically it has happened. Like look at the leaf, how symmetrically, right? If you want to make by yourself, perhaps you can make it. Huh? But how nature has gifted. Look at the flower. How symmetrical. Look at the color. How symmetrical. Take any, the champa, chameli, jo bhi flowers to you can see that, right? The color, the shade, and everything. Okay? So everything nature has already gifted. Okay? And there is a pattern. You can see that. Whatever you see outside, there is always a pattern. And don't think that it has just happened by chance. No. It has happened for a reason. Everything has happened for a reason. The evolution also has happened for a reason. Okay? That's why the sustainable thing is there. In the forest, there is a tiger, and then there is a deer, and then there are plants. So then the equivalence actually, about 20 years ago, Australia had to kill millions of kangaroos. Now we get excited sitting here, kangaroo, Australia, no? Famous for kangaroos, right? But they had to kill it. Emus, you know emus? Emus, there is the tall bird. Because they simply outgrow in numbers. They come actually and disturb actually in the farmings and this and that. They have to kill. Okay? So therefore, the nature has created actually an ecosystem where everything is in balance. And that is all data, everything that you notice, there is a pattern around it. Okay? One good example after this, you go and look at, very closely observe a flower or maybe a leaf. Totally symmetrical, as if actually someone has measured it. Okay? So now, on the data, we would like to know the pattern between the data. Once we understand the pattern between the data, we can create a mathematical formulation for that. And then we can use whatever we want. That's what we say, learning the trend of the data. Trend means that is the pattern of the data. The relationship between the data. If X exists, does Y exists always with it? Or X, Y, is there a relationship between with C? So those kind of localized relationship that we need to understand. And we cannot do it by ourselves. So therefore, we need to develop the mathematical model or computational models. Are you getting me? Everyone behind? Okay? Good. So that is where actually we build these mathematical equations, and that is where this artificial intelligence has come. But again, it's an artificial, as the name indicates. The natural intelligence is here. Okay? You train a computer will behave certain way. You have seen the Chitti now in that movie.
Yes.
Right? Because you train, right? But we have that unique ability of certain aspects that a machine will have. For example, emotion. Emotion. Human being is an animal. 100% is an animal. Like any other animal, we are also an animal. But what makes actually distinguishing from the animal kingdom between us is that we have certain distinctive features that they don't have. One distinctive feature is that is called the ability of imagination. No animals has that. Sitting here, you can imagine another universe. Sitting here, fractions of second, you can go to New York, walk around in the alley of New York and come back. Right? Imagine it. You look at actually your dog, you think actually he's imagining something, daydreaming? No. What's important for is that food. But dog does has emotions. Cows does has emotions. There are animals that has emotions. Certain animals has got emotions. Okay? But on top of that, we have motion. And when we make a decision, it does plays very important role in our decision making. Right or wrong? And it is embedded in our system. Yeah? In our genetic system. Okay? The certain ways we take decisions, the certain way we react to an environment, to a particular situation and everything, there's a whole bunch of parameters goes in making a decision. It's not just what, 0 or 1, right? But computer, if you do not train, it can just make 0 and 1. Okay? So that is why the complex modeling processes have become popular, like the AI. But again, the problem with AI is that it's a black box. How the artificial intelligence is making a particular decision, it doesn't explain. So when it is not being explained, there is a lack of trust, right? Because if I make a decision, if someone asks me why the decision has been made, I can explain. Because of this, because of that, because of this, because of that. Right? So that is why, lately in the last 3 to 5 years, the new generation of advanced machine learning models called as XAI. Explainability AI is getting very popular. I'll give some lectures on that as well. Next week. Okay, once you go a little bit advanced. This is just a trailer. Okay, so explainable AI is also getting. So explainable AI, what happens is that how the decisions are being made can be explained to some extent, so that there is a logical explanation to it. Then there is, you can build the trust how the decisions are being made. Okay? So here actually I have put a very nice example of it. You know, like when you buy a Lego box, you don't buy, maybe for the kids, you know, they buy. They bring that thousands of Lego pieces and then they take and then they just, you know, put it in an order actually to make some. Yeah. Initially, if you look at it, these are data, for example, right? Initially, if you look at it, thousands, 5,000, 10,000 pieces, how are you going to join it? It looks mind-boggling, right? But then, with the Lego works, it comes with actually a small instruction. So that small instruction, what you call actually is the engine. That's why you have the input data here. Oh, can't. You have the input data here. Then you have the engine. Then you build all the mathematical models there for a prediction. Prediction means if scenario this happens, what will be the outcome? If scenario this happens, what will be the outcome? Okay? Now, all this technology, geomatics and geospatial computing, they are, as I mentioned, geoinformatics or geomatic or whatever you can call it, there are different kinds of equipments that is being used as well. Okay, such as the laser scanning systems or LiDAR systems. Then you have the GPS systems. Then you have the satellite systems, the drone-based systems, and so on, blah, 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 blah. Okay? And so geoinformatics plus the GIS and surveying is what is called the geospatial computing. Okay? And essentially it has got three pillars. You see it is remote sensing here, then you have GIS there, and then you have the GNSS. GNSS means Global Navigating Satellite Systems. That means the GPS comes from there. Okay? And then you might be noticing there are so many branches, they name or coin different kind of names, like cartography, geodesy, and so on. So depending on which component of it is being utilized, that's how the name changes. Okay? Photogrammetry, computational geometry, and geoinformatics, and etc. So the entire branch of remote sensing started off from electrical engineering department. If you look back at the history. Actually, the history starts with the kabutar. History starts with the kabutar. Then slowly they realize, okay, if you train the kabutar, then you can put a small camera in it, then it can actually take some photos. Hey, don't laugh. That was the history. Okay, but then kabutar is not going to listen to you all the time. If you want him to fly one place, you would go to another place, right? It doesn't have a GPS tracking system, right? So then slowly they started building the balloons, right? They started using the balloons. Then aircrafts, and then da 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 da. In the last 40-50 years, the whole technology has rapidly changed. And now we have launched the these Galileos and these but we are doing even deep space exploration. That means we have gone almost how many billion light years from here? You know? So when we say billion light years, when you go to the clear sky at night, you look at actually some of these constellations, right? And some of them, that what you see, maybe they don't exist today. Right? The light that you see, maybe it is like 10 billion years ago. The incident has already happened. Because it took 10 billion years to reach the light from that here. And that's what we see. 10 billion years old event. Right now we don't know.
Some other galaxy maybe seeing our
Oh yeah, that's why called multiverse. Quantum computing is all about it. Yes. So I told you, right? NASA has discovered the signal. Maybe there is another. Some of us actually, this process is happening or has happened. You do not know. You just do not know. Our inability actually, we don't know. We don't know even our own Earth. Earth is switching its North Pole becoming South Pole, South Pole becoming North Pole. You know, we are just understanding. We begin to understand. There is a shifting of the poles as well. because we found the track record that, oh, okay, because when the mineralization happens, in volcanoes happens, immediately some of the minerals crystallize. And always they crystallize, especially the minerals which has got iron content, it would be always aligned towards the north pole. Iron always would align to the north pole. So that is a great indicator of how the poles has been shifted. Now we are in the middle of actually changing of the pole. And we don't know exactly when it will happen. If it happens, whether it will be snap off, we don't know, we have not experienced it. Because the whole process takes about 450,000 or something like that. That's what they say. Okay, but we haven't experienced it. Okay? So a lot of things that has been gifted to us. Yes.
So they have lunch.
Oh yeah, yeah. So stop me, I'm telling you.
We do love to